Hello everybody, my name is Nikolaus Flöry from Vario-Optics. We are here at Basel, at ECOC in Basel, Switzerland, and I'm very happy to show you now our demo board, which we are running here at the Kobo booth. At Vario-Optics, what we are developing and producing are electro-optical circuit boards. This is an example of such a hybrid board. It looks like a conventional PCB board, but in fact there is an optical layer laminated right in the middle. So the actual stack up of such a board is 20 electrical layers, and in the very middle there is one optical layer which hosts multi-mode polymer waveguides, which were produced at Vario-Optics. This is the bare board of this demo. Here we see a fully assembled one. This is assembled with a few standard off-the-shelf components, transceivers, an FPGA to run the entire board, and it's set up here for a demo to show that we can do onboard optical data transmission. I have a program running here over the FPGA which drives the transceivers and which now displays 4 channels, which are each operated at 25 gigabit per second. So what we're running here is actually this corner of the board right now. There's an optical transceiver with 4 active optical channels. They're connected to the optical waveguides in the middle of the board, and there is a loopback which route the light back to the transceiver. And what you can see here on a display is that we have clear eye openings, so the data transmission is going well, and we're fully going through the optical waveguides. An advantage of using these optical waveguides as compared to optical fibers is simply put that we can reduce the amount of fibers and the overall fiber bundles that we have on top of such a board. So you see there are actually only very small connections between the transceiver and the waveguides, and even those are the interfaces that we are further working on to reduce the amount of fiber being used even more. You see there are certain lanes of optical waveguides on such a board. There are some straight lines going from one edge to the other one. There are some loopbacks which are connected either on the edge of the board or in mid-board. And in fact, we can route light in any direction here on such a board. There are certain limitations or certain design rules which we have to keep in mind when having electro-optical co-design. So we need to have some clear spaces around the waveguides for electrical wires, for example. But other than that, we can freely use the space on such a board, and thereby we can multiply the number of channels which are operational. Right now we only have 4 optical channels which are here demonstrated, but in principle we could have hundreds of optical channels all running in parallel. We're running a 25 gigabit per second optical signal right now through the waveguide, and as we see the eyes are clearly open, so there's a very low bit error rate, and the limiting factor is actually the transceiving element. So if we have faster transceivers, we can increase the data rate up to more than 100 or 200 gigabit per second through such an optical multimode waveguide. On this board we have a 50 micron optical core waveguide. You can also have a different size core. Vario-Optics is capable of producing core size of about 2 micron for single mode up to 50 micron multimode, but also larger cores of around 100 or 200 micron core size, depending on the application and the transceiver element. If you're interested in more information, feel free to reach out, contact me, or visit our homepage or LinkedIn account for more information. Happy to discuss and show you more about it.